There are about 3 or 4 big theorems that we have to know on the AP test. They're on there every year. This is one of them right here, intermediate value theorem. I know sometimes we get a little intimidated by that word theorem when we have to work with those, but these really aren't all that bad, all right? The language looks a little bit worse than what it was, so I'll talk about that in a second. But intermediate value theorem just says this. It says if you have a y value down here and then a y value up here, all right, and you got it's just saying that you're going to cross through all those y values in between. There's going to be some x value that corresponds to that y value that's in between those other two y values. So for example, like if this is a y value of 2, this is a y value of 10, k could be any number in between the 2 and the 10, and then there's a corresponding x value where that y value is equal to any number in between 2 and 10. So if on the AP test, you start seeing any type of weird language and stuff there, they're probably talking about a theorem. If you see like, hey, why is it must be true? Explain why this has to be true. And they talk about, hey, there's a table of velocities or accelerations, and you see a velocity of like 5 and a velocity of 100, and they say, why does a velocity have to equal 27? Well, guess what? 27 is in between that 5 and the 100, right? So you're gonna just, is all it is intermediate. It's just in between the two values there. That's all that is. Now, when I'm doing these two examples, that's all we got, 2 quick examples. You have to make sure it's a theorem, it's a proof. So you got to make sure, I'm not writing down a lot here, but whatever I write down, you have to model that for your homework, model that for a test situation, and we have to be very careful how we justify our answers there. But it's going to cross through all the y values in between as long as it's a continuous graph, right? If it's not continuous, then all bets are off because it could just hop over that k value right there. So that's what this is saying. It's continuous in between a and b, and then you have 2 different y values. F of a is not equal to f of b, and k is any number in between the f of a and the f of b, all right? There's just a point that we're going to find the x value. So when we plug that into the equation, we're going to get that y value right there. So that's what the technical language is. Now, there's 2 different setups. The one just says show that it has a 0. The other one says show that it's equal to 3. So if it wants me to show that something has a 0, this is a special, easier case of the intermediate value theorem. Let's use some common sense here, right? Show that it has a 0, that's where it crosses the x-axis there. So one, I got to make sure I can show that something is continuous. And then if I could show if it's continuous, if I could plug in like the endpoints of my interval, let's say I were to get a negative value and a positive value. Well, if I have a continuous graph and to get from my negative value to that positive value, I can't lift up my pencil because it's continuous. That means it has to cross the x-axis right there. So we want to establish it's continuous, and then we want to establish it has a positive and a negative value, and then we're done, all right? And we have to write all that down. It doesn't matter what's going on in your head. You must write that down on the paper, right? It's a theorem problem, it's a proof problem. So what I'm gonna do, when it says show that has a 0, when we see polynomials are our friendly functions. They're always smooth and continuous. There's no asymptotes because there's no denominators or anything like that. So, but we just have to write it down. So the first thing I'm gonna do is just write down f is continuous. Now, technically, it just has to be continuous in that interval. So sometimes we may have functions that aren't continuous everywhere, like this one is, but it is continuous in that interval right there. So we just got, to look at the function right there. But if you see a polynomial, just say, hey, it's continuous. So we got that satisfied. And then we talked about over here, I'm going to take the endpoints of the interval, like the 0 and the 1, plug those in place for x right there. So I'm going to do f of 0, and I'm going to do f of 1. And let's see what we get. So if I plug in 0 for those x's, I'll get a -3. If I plug in 1 for those x's, I'm going to get 1 plus 5, which is 6. 6 minus 3 is a positive 3. And then notice that we just reasoned out over here. We got the couple things that we needed right here. So then this is what I'm going to stress there. Okay, I'm just going to say that f has a 0 since f is continuous and changes from negative to positive. Or you can say f changes sign. AP test, I'm going to tell you, chapter 1, do not use pronouns. They hate pronouns. The do not like that. You don't say it is continuous or it has a zero. Say what is continuous, what changes sign. So, because we'll do stuff with the original function, the first derivative graph, second derivative graph. So just let's develop some good habits now. But see, that's an easier problem if I have to show it has a zero. But see, you just model that in the homework. If I give you something like that, a test, just kind of model that there. It'd be pretty easy. All right, now this one here gives us a function in an interval, but then it says not show that f of c is equal to 0. It wants to show f of c is equal to 3. All right, so it's not just as easy as getting a negative and a positive value, because if you're going to show across through 3, then you're not going to necessarily have a negative value. You could, but let's just see what's going on here. So first thing on this, the directions are going to say show that the IVT, the intermediate value theorem, applies, and then find the value of c guaranteed by the theorem. Just if you want to connect to that theorem above, that's your k value right there. Now, if you're going to show that it applies, there are 3 stipulations that make it applies. It has to be continuous, f of a is not equal to f of b, so you got 2 different y values, and k is a number in between those 2 different y values. So 3 stipulations, we must write all 3 of those down. So I see a polynomial, so I can just simply write down f is continuous. So that's one stipulation. Got that knocked out. Next thing I got to do is f of a not equal to f of b. So this is the a, this is the b. So I'm going to take the 0 and the 3, and I'm going to plug that in place for the x's. So 0, so minus 0 plus 8, that's going to be 8. And then f of 3, that's going to be 9 minus 18, which is negative 9. Negative 9 plus 8 is a negative 1. Okay, and so right there, those are my f of a and f of b. So f of a is not equal to f of b. Notice that I got those. So I show what those are equal to. Those are not equal to each other. And then the third stipulation for this theorem to apply is k is any number in between that. And this is my k value. So then I have to write that down because it said show that the IVT applies. So I'm just going to simply write down 3 is between negative 1 and 8. So boom, 3 stipulations, 3 check marks. That's this first part showing that the IVT applies. And then once the IVT applies, we're going to find the value of c guaranteed by the theorem. So the theorem guarantees that f of c is equal to k. So it gives us this f of c is equal to 3. That's the y value. So it's just we have a y value at negative 1, a y value at 8, and now we're going to show that there's something where the y value is equal to 3. So technically, we're taking the c, plugging in there for the x's. Now, you can leave it as x's or you can change it to c's. I don't care. But the main thing is this 3 is the y value. So I'm just going to leave it. So I guess we could use the c's there, or you can use x's. It doesn't matter. So I'm going to go c squared minus 6c plus 8 is equal to 3. You're going to set that function equal to 3. And then we're going to solve this equation here. So we'll get c squared minus 6c. We're going to get a plus 5 equals 0. And then we can go ahead and we can factor this thing there. So it'll be minus 5 minus 1. And then we're going to get c is equal to a 5 and a positive 1. Now, we got to check our interval. It says in between 0 and 3, which means we don't care about this guy right here. We're just going to have that. So the intermediate value theorem, it says an existence theorem. It just says that something exists. There might be more than one. Graphically speaking, so we're done with this problem right there. You don't have to do anything else there, but just be a little bit careful with the theorems. We will learn this theorem here. We're going to learn a couple more big theorems in chapter 3, and then they kind of go away for a little bit. There's something a little bit in chapter 4, but it's more algebraic and it's easy to just compute stuff. And then we're going to forget about it, but we'll review it when we do our AP review. I already have our theorems on one big sheet of paper that we will have everything in one spot on our study guide there. Graphically speaking, what you just figured out, if you graph this parabola, it looks something like that. And notice that you have a y value at 8, and we plugged it in. So we had the 0.08, and then you had the 0.3 negative 1, which is down here. And then notice that you have a y value at negative 1, a y value at 8, and then it says show that it crosses through a y value of 3. So notice that it crosses through a y value of 3, like right here and right here. There's 2 spots where that happened, and we technically found both spots, but it just says in between the 0 and the 3, which is, just in between x equals 0 and x equals 3. So that's why we're just concerned about that point, over here. So that's what you're figuring out. Hey, you're figuring out, hey, I got the point. My x is 1, my y value is 3, and there you go. And you can even check that. 1 minus 6 is -5. -5 plus 8 is a +3. So just be a little bit careful. Just got to get you exposed to the big theorems and practice those a little bit, and then move on to different things.